Today, we Group 6 will be presenting our project, which is an aquatic multipurpose robot for water surface trash cleaning and water quality monitoring. Today, we'll be presenting to you its dynamic functions, which makes it a very unique project which is to be used in the current status quo. We'll show how its primary function, which is collecting garbage and trash, and by trash we mean plastic bottles, leaves, plastic bags, any unwanted objects on river bodies. Second, we will show how it can be remote operated and can be controlled from a controller room very easily and conveniently. Then we'll also be showing you how it can detect water quality. For example, it can measure the temperature of water it is in. And also we will see how it is built based on eco-friendly products, which makes it a very cost-effective product at the end of the day as well. The idea for this project came to our minds from thinking about the current status of river pollution in Bangladesh. To save our environment, it has become a vital need for us to protect our river bodies. As we can see from the picture that currently the cleaning process is highly reliant on manual labor, which can be time-consuming and unhealthy as well. Hence, we have come up with a technology which can carry out this task without having to rely on foreign technology either.
So here we will discuss about the structure of our water cleaner robot. We have mainly built our structure with recycling materials like plastic bottles and PVC board. Plastic bottles are very easy to find and it also helps the robot to float on the water. To support the bottle structure, we have connected PVC with each bottle. We have also made the wheel which drives the robot in various directions with PVC materials. So here we can see the arm which collects garbage from the surface of the water. We have made the frame of the arm with PVC sticks and connected iron net with the stick. The iron net helps to collect waste like empty cans, bottles and leaves and dump them into the bin which is situated in the middle of the robot. So from the picture we can see the waste collector bin is situated in the center of the robot. For convenience we have made the bin easily detachable so that we can clean the bin and take out the garbage from it. So this is our control box of the project. We have kept all the circuitry in the control box to avoid the splash of water from entering in the circuit. And on the top of the control box, we have placed our camera module for better viewing angle. We have used a smartphone as a camera module of our project. So that's basically the structural part of our project.
In this part, I am going to describe the overall circuit diagram. At first, for moving our boat, we have connected two high-torque DC motors with the four output pins of the L298 motor driver. The motor was powered by 20-volt DC LiPo batteries which are connected to the VCC and ground pins of the motor driver. The direction and the speed are controlled by Arduino Mega, which is also connected to the motor driver. Arduino Mega is powered by a 5-volt battery and a Bluetooth module is connected to it for sending the wireless command to the motor driver via Arduino. Secondly, for collecting the trash, a servo motor is connected with a sieve. A buck converter is used to step down the 20-volt DC voltage to 6-volt for powering the servo motor. At last, the temperature sensor is connected to Arduino Mega for measuring the temperature of the water. Here the specification of the equipment we have used for building the previously described circuit. For attaining 20-volt DC voltage, we cascaded two 11-volt LiPo batteries. We have used two 12-volt 100 rpm DC motors with high torques and two servo motors that can rotate 0 degrees to 180 degrees. A Bluetooth module is used for transparent wireless serial communication. We have also used a buck converter for its high current capability as servo motor need a high current for working. We use a temperature sensor that can measure temperatures from -55 degrees centigrade to 125 degrees centigrade. We set a camera module on our boat which is connected with Wi-Fi for controlling the boat from the control room, and a H-bridge motor driver is used for controlling direction and speed according to our requirement.
For controlling and monitoring part, we used three different apps. First app shows us water quality that is being detected and transmitted through the Bluetooth module. The second app is used for controlling the boat. We used an RC car controlling app. For forward movement, both motor runs forward direction, and for backward movement, both motor runs backward. For going forward left or right, the opposite motor runs forward direction and the other motors halt. For hard turn, one motor run forward direction and the other motor run in opposite direction, so the boat will turn its face without moving in any direction. And the car's front light and back light is used to pull the arms up and down. The third app is used to get video interference of the surrounding of the boat in a monitor, so that we can monitor the situation from far.
Here is our project demonstration part. Now we will see how this robot collects garbage and measure the water quality, more specifically the water temperature. We make this video in front of Ausanullah Hall. There is a small pool and we put some garbage and then test our system in the pool. We can see the different parts of our project in the video. From the top we can see more clearly. Here you can see our control unit where all circuitry is kept. Now we can see that the robot collecting bottles, plastics and thermocol pieces. It has good control ability to change its direction. We have received footage from the attached camera into laptop, which will be shown in later. By using this footage, we gave the directional command from our mobile app, which we can see in the left bottom corner. Besides, we also gave command to uplift the weights in the robot. Here is the view from the attached camera, which works as a camera module. We have used a smartphone as a camera module. Watching this footage from a remote room, anybody can control the system. Finally, here is our water quality measurement. We can see the water temperature sensor. We cannot use other sensor to measure quality like pH because of too much cost. We receive the temperature in the mobile app, which we can see in the video.
Limitation: this machine is able to collect the waste which is only floating on water level. Weight capacity is limited. Improvement in future: structurally, we will improve this water surface trash cleaning robot automation. It enables the scanning and cleaning process with the help of a trained deep learning model. Better motors, better garbage collection method, increase the weight capacity. The machine can be designed for also deep cleaning, turbidity sensors, and pH sensors for high accuracy water quality monitoring. Industry implementation. Initial and maintenance cost is low. The project is very useful for small as well as big lakes, rivers where garbage is present in large amount. Skilled workers are not required to drive the system. Environment-friendly system. Design of the system is made simple.
In order to automate this entire robot in the future, we have trained a deep learning model to detect this trash plastic in real time using YOLO v5 algorithm.